Okay, it's critical that you understand, in order to solve systems of equations, that you understand how to solve a simple equation. And now we're adding two variables instead of just one. So normally we just have one variable. So you really need to understand solving equations, which is a matter, all we're doing with these equations is undoing. But with two equations, what we want to do is try to get rid of one of the two variables. Okay, so we need to make the amount of variable in each of the equations match each other. So I'm going to demonstrate with this entire page, and then there's another page that's exactly like this. So our learning target is I can solve a system of equations. A secondary learning target is I can write a system of equations. Okay, so when we look at these problems, we have to think about what we can get. We have to think about what the problem is asking us. Okay, so when we take a look at the first one, Jacob bought some tickets to see his favorite singer. He bought some adult tickets and some children's tickets for a total of 9 tickets. Okay, and you can see adult, he's using the letter A, and children, he's using the letter C. And he has a total of 9 tickets. So however many adult tickets plus however many children's tickets equals 9 tickets. The adult tickets cost $10 each, so you can see here he multiplied by 10. And the children's tickets cost $8 each, so he multiplied by 8. He spent a total of $76. Okay, so logically that's how the two equations come together. Now, to eliminate one of the two variables, we have to make the variable, the number in front of the variable, exactly the same or exactly opposite. In other words, if I had a 10 and a negative 10. And we have to do that because we're using a process called elimination. We want to eliminate one of the two variables and solve for the other one. We only know how to solve for one variable. So the first equation, first off, I'm going to write the first equation out, and then I'm going to think about what I can multiply by to make either the number of A or the number of C match the second equation. Well, you could multiply by 10. That means we're multiplying every single thing, the A, the C, and the 9 by 10. Or you could multiply by 8 because then the C's would match. Okay, the idea is to make them match. So I'm going to choose to multiply by 8. That means that I have 8A. 8 times A is 8A, 8C, and 8 times 9 is 72. Okay? Now, because the 10A is larger than the 8A, I write that above. And the 76 is also larger than the 72. I only do that because then I don't end up with negative values involved. Now, the trick here is we want to get rid of. So we have a positive 8C rather, and a positive 8C for both of them. So the only way we can get rid of them is to subtract. So I put parentheses around the entire second equation, and that means that each term in the first equation is going to subtract the like term in the second equation. Okay, remember we can't combine terms that are not alike. So I have 10A and I'm subtracting 8A. That gives me 2A. I have 8C and I'm subtracting 8C. Those wipe out. Those zero out. And then I have 76 and I'm subtracting 72, and that gives me 4. So I have 2A is equal to 4. Well, just like any other equation, my last step is to divide. So I'm going to take 2 and divide it by 2, and 4 divided by 2, and I get A is equal to 2. A stands for the number of adult tickets. I bought 2 adult tickets. Now you can figure the rest of this out on your own by, I'm not going to make you do that, but the way that we do that is we plug the 2 back in for A in one of the 2 equations, the original equations. So I'm plugging it into the first one because it was just 1A. And we know that the total number of tickets bought was 9. Well, what do we have to add to 2 to get 9? We add 7. If you're unsure about that, all I'm doing is following through solving the problem by subtracting 2 from both sides. So a problem like number 2, Sophia's school took a field trip. A total of 21 vehicles were needed for the trip. Some students took the bus and some students carpooled. There were 30 people on each bus and 4 people in each car. 318 people attended altogether. So again, we've got to set up 2 equations. Well, I know that buses and cars both went. So I'm going to put buses first and cars, and the total number of vehicles was 21. Don't know how many buses yet, don't know how many cars. I also know that 30 people can fit on the bus. So if 1 bus, 30 times 1. If 2 buses, 30 times 2 is 3 buses, and so on. And the number of people that fit in each car is 4, and all together 318 people went. Okay, so I take those 2 equations and grab the wrong papers. Oh, there it is. I take those 2 equations, and the way I want to do this is I want to figure out how to make one of the numbers in front of the B or the C equal to the second equation. So either the number here I want to turn into a 30 by multiplying by 30, or the number here I want to turn into a 4. Well, the easiest one is to multiply by 4. So I'm going to take this entire equation and multiply by 4. Okay, this is distribution, and this is a weird distribution because we got an equal sign in there, but we're multiplying everything in there times 4. So 4 times 1 is 4B, 4 times 1 is 4C, and 4 times 21 is 84. Now, the way I always do this is I figure out which number, the number by itself is the largest, and I place that over top of the other equation. So that equation looks like this, 30B plus 4C. Now you can see that the C's match, right? I've got a 4C here and I've got a 4C here. Well, think about what would happen if I take 4 and subtract 4. It's going to zero out. That's my goal. So I'm going to subtract. 30 take away 4 is 26B. 4 take away 4 zeros out. And 318 take away 84 is 234. And now I have 26 times B is equal to 234. So all I have to do is divide by 26. Divide by 26, and I get B is equal to 9. If there are 9 buses and 21 vehicles total, it's a simple subtraction problem, because the number of buses plus the number of cars is equal to 21, so I just take 21 and subtract 9, and I get 12. So 12 cars went and 9 buses went. Okay, next one. Ethan's football team scored a total of 35 separate times this season. Now, sometimes they're scoring touchdowns and sometimes they're scoring field goals. Each touchdown is worth 7 points, and each field goal is worth 3 points. So the total of the touchdowns plus the field goals, they scored 35 times. Each touchdown is 7 points. Each field goal is 3 points. And they scored a total of 193 points. Okay, so I've got to take a look at the 2 numbers. The easiest one again to match is the 3F. So I've got to take the entire first equation and multiply by 3. So I get 3T is or 3T rather plus 3F. 3 times 1 is 3. 3 times 1 is 3. Then 3 times 35 is equal to 105. Larger number goes on top. And so I have 7t plus 3f. Again, I want to zero out one of the two variables. So I'm going to zero out the second one by subtracting. 7 minus 3 is 4t. 3 minus 3 is 0. That's gone. 193 take away 105 is 88. And so I take both sides and I divide by 4. And that gives me 22. That's the number of T's, or touchdowns. So they got 22 touchdowns. Altogether, they got 35 total scores. So the rest of them must be field goals. 35 take away 22 is 13. So we have 13 field goals. And we went to the movie theater for her birthday. A mix of adults and children attended, making a total of 19 people. So adults plus children equals 19. Okay, number of adults plus the number of children is equal to 19. Each adult ticket was $9. $9 for each adult, and each child ticket was $5.50. Now the 0 is unnecessary, so I'm just going to put 5.5 C, and the total amount of money was $150. Okay, the easiest one to match now is the 9, because I don't want to have to multiply by 5.5. So I'm going to multiply everything in the first equation by 9. I get 9a plus 9c equals 9 times 19 is 171. And I have 9a plus 5.5c equals 150. Again, I subtract. Why? Because I have a 9 and another 9. I want to get rid of them. That zeroes out. Then I have 9 minus 5.5. 9 minus 5.5 is 3.5. 171 minus 150 is 21. Divide by 3.5. Divide by 3.5, and I get C is equal to 6. If there are 6 children and 19 total, we take 19 minus 6, and we get 13. Okay, and that's that. Noah's class held a food drive for the holidays. There are a total of 25 students in his class. On average, each boy and each girl brought in 3 cans. So the number of boys plus girls is equal to 25. This one's kind of a weird one. Each brought 3 cans in. So boys times 3 and the girls times 3. And the total is 75. Okay? And we're asked to find out how many boys and how many girls are in the class. So, in order to match, I want to multiply by 3. So I get 3b plus 3g equals 75. And my original was 3b plus 3g equals 75. So no matter what I do here, if I subtract, everything's going to zero out. I'm going to get 0 equals 0. That means we cannot figure out how many boys or girls. We don't have enough information to figure out how many boys or girls. Unknown. Okay, you run into that sometimes where everything wipes itself out. And then finally, Olivia's family drove to Disneyland for spring break. Her mom and dad shared the driving duties for a total of 14 hours. Okay, mom drove some, dad drove some, and altogether they drove 14 hours. Her mom drove 65 miles per hour. Her dad drove 60 miles per hour. And they went 895 miles. Okay, so again, we have to match either the M or the D. easiest one would be multiply by 60 so that the D's match. 60 times M is 60M. 60 times D is 60D. And 60 times 14 is 840. Larger number on top. And so I have 65M plus 60D. And again, I want to subtract. Because I have 60D and 60D, both equations have the same thing. If I subtract them, they zero out. Well, 65 minus 60 is 5M. Those zeroed out. 895 minus 840 is 55. And when you divide 55 by 5, you get 11. So M is equal to 11. So Mom drove 11 hours, and we had a total of 14 hours. So 14 take away 11 is equal to 3. Dad only drove 3 hours. He's a slacker. Okay, now match this to your classwork. It's the same process, same types of problems.